Hello and welcome to Crash Course NASA. My name is Sean Gatewood and today we are going to be talking about the technology used in the recent mission SuperTIGER. SuperTIGER, or the Super Trans-Iron Galactic Element Recorder, was a mission that was designed to investigate the mystery of cosmic rays. So, cosmic rays, what's so great about that? Cosmic rays are one of the best ways to directly study matter that has originated from somewhere outside of our solar system. And SuperTIGER is the coolest mission in the entire universe because it's a balloon. Now, I know what you're thinking. What? A balloon? I've had balloons since I was 2 years old. Well, these aren't just any balloons. These are LDBs, or long-duration balloons. This particular one was a record breaker. 55 days in the air. These balloons, which use helium just like any balloon, are made with a special kind of material that makes them very lightweight and durable. They're connected to the payload, and usually the material through here is part of the parachute for the payload when it is released. Because we want to reuse these payloads, they're pretty expensive. There's usually a releasing mechanism in through here too, which is activated by radar. Now you might be wondering why the mission doesn't use something cool like a sounding rocket, but you see, the payload needs to stay in the atmosphere for a very long time, so a rocket would not be very effective. Now I misspoke earlier. I said that the releasing mechanisms of the balloon are activated by radar, but it's actually radio. Now, you see, radio is very effective for many NASA missions. The only other alternative would be... Hey, John, I think I reached the balloon. Ah! It's the same technology that's used to drive the Mars rovers, which are, really far away. But how do radio communications work? Well, let's go to the doodle board. Do 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 doodle doodle board do 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 do. Alright, so here's NASA right here. Draw a little NASA guy. Maybe. There we go. So our NASA guy right here has something called a transmitter. And this transmitter is going to send out radio waves up to the balloon. Remember, our releasing mechanism is right here. Now these radio waves go out in pulses in a certain way that the releasing mechanism recognizes the pulses, and it releases the payload, which falls to the ground, except instead of being destroyed, there is a parachute. I cannot draw a parachute. And that's how it works. Keep in mind that the instruments on the payload also send signals back, which are read by NASA's computers and analyzed. Now, I mistakenly said radar for radio earlier, so why couldn't we use radar? Well, radar would be great for telling where the balloon actually was, but it couldn't actually make the balloon do something, such as release the payload.
So when the payload is finally released, how do they find it?
Good question. Why don't we go to the doodle board again?
Oh wait, we already did the jingle.
So the payload is released, it falls down with a parachute so it doesn't break, and it lands somewhere out in the wilderness. So in order to find it, there's a little microchip here. So when NASA doesn't know where it is, they send out a signal via a reader. And this reader sends out radio waves, which activate the microchip, which sends radio waves back, telling them where the location of the object is. Of course, this communication here is not completely direct. That would be something called radio frequency identification, or RFID. This is not as effective as using a satellite, which I cannot really draw. The satellite determines the payload's location and tells the NASA workers where it is. Then they bring out a bunch of trucks, and it's a big operation, but they get the payload back. So let's review. The instruments on the payload up in the high atmosphere on the balloon take a bunch of measurements, and they send them by radio down to NASA's computers. They analyze the data, and when they're all finished taking measurements, they signal for the balloon to release the payload. The payload falls to some random place on the ice in Antarctica, and then the tracking microchip signals where it is, so NASA can find it and recycle it. Alright, any questions? You?
How do technologists work with engineers in this mission?
Well, the engineers develop all the technology we talked about, and the technologists are the ones that actually put it into use. You?
What role do technologists play in this mission? And, what technical jobs are specifically required?
Well, they have to operate all the equipment. Well, they have to launch it, they gotta control while it's in midair, they have to release the balloon with the releasing mechanism, and then they have to go find that payload so they can reuse it. Any more questions? You? How do those trade workers collaborate with the technologists? The trades workers really help with retrieving the payload after it's released, because they have to bring the trucks out, they have to load it onto the truck, and then bring it back to the base. Well, that's all for today's episode of Crash Course NASA. I'm Sean Gatewood, and as always, think outside of the troposphere.